So back again. I actually realized that this is basically a mistake, because the way we want to do it is we know that each no bit, right, doubles the possibilities. So what we can do is we can have this bit determine which one of these two we will use. Oh no, it's the deactivate bit. It's the deactivate thing. Here we are. Having built this, will give us 16 addresses. So now what we can do is take this one to determine but then we would use we can also use a decoder instead of this. I know that I've already built this in a scalable manner already. Anyway, for now this is gonna do it. This is gonna be fine. I want to exceed what we were about to do at this point, because then if this will be exceeding what we were supposed, like not supposed to, but what we wanted to do. This series. I mean, at the end of the day, maybe you might be able to. We want the component to look a little bit different. You would be able to figure out how to do this on your own. This is fine. So this is arc 1. This is argument 2. And this is the result. Address. Right? With this video series. At least at this point in time. So now we don't only have 8, but 16 registers that we can address. This is great. Maybe we actually want to do this the other way around. gonna be more. It's gonna be easier to remember how it is built if we just go top down. Now we're actually going to pull out a screenshot. Since I don't remember what exactly we want to do with this component. Want to, or we're gonna have to, if we want this to be great, right? You know what I'm actually going to do is I'm gonna have a look at my other account. See how I've built it back in the days. Maybe I'm gonna do it in another video and just record this one, see where this will lead us. Argument 1, argument 2, result address. This is only supposed to be for registers, right? Wait, memory address? Do we add a RAM? Yes, we add a RAM. It calls for memory. Registers, counter, input outputs. No, this level doesn't call for RAM. Back to the component factory. It's just supposed to load. We're going to do it this way. or this way. We're going to do it this way. We're going to use switches as well, because the switches will be used. So 1, 2, 1, 2. Maybe we're going to actually use these colors. Determine the bus on which we put the argument, or rather the value that is stored. So we're going to use yellow. This is not yellow. This is actually yellow. It's gonna be, well, yellow and green, I guess. Since we cannot simply it's gonna give us the address, right? Simply load the register because we want more than one register in many cases. That we load from. And this is gonna ruin our bus, as we've learned in one of the previous videos. Or rather previous levels. This looks great. Hopefully these are not connected to, they are connected to the wrong registers. Oh, this is horrible. So you're great. So that means we're going to delete this whole lower part and replace it. Blue. Blue is gonna be used for the result address. Interestingly enough, the result itself is on a purple line. So let's use a purple line for the result. You see, I have many, or rather, a couple of possible variants of this in mind. It's hard for me to decide which one I actually want to build for us. Oh no, it's gonna be this one. So as we've said, purple carries the result. It's a little bit tighter. And copy this structure of cables to place it. Oh wait, why aren't you? Just gonna build this one so we can finish it, right? It is what the level demands. Maybe I was just a little bit ambitious to go this big at this point. So you are to save. Okay, we're going to do it like this. This is gonna be the way that we address. Our registers. This is safe, yeah, this is correct. One, two, three, four. I was just thinking if this is correct, right? And I think it is. Because this will display the numbers from 1 to 8. And or rather 0 to 8, and once 8 is lit, that will mean we deactivate this one, and then this would be the numbers from 9 to 16. Actually, how many do we have? So 4, 8, sorry, 12, 16. Add a lag. yeah, this byte is going to determine the position. See, if we were to add the next 8, we were to create 2 new, on the next 16 rather, create 2 new, then we would use this one with a decoder that would first of all deactivate both of them, right? Maybe it would feed into this one. No, this is not possible, because this would have to be a one-way. Alright, it is gonna deactivate both of them, and then count up again. From 1 to 8, which would activate this one again. And then we would use this decoder once more to determine which one of these we were actually addressing. We are actually addressing. And this will give us 32 possibilities. And I guess instead of doing it like this, we could actually build it the way I initially built it. Take a three decoder, or 3-bit decoder rather, and then determine, like, depending on these 3 bits, eight of these 8-bit decoders, which would give us 64 possible addresses. But then we still wouldn't be able to, we still would have two of these left. Let's go. Let's actually do it like this. I said I was going to build it scalable. Now that we are at it, which one are you going to deactivate? Like, all of them are deactivated by default, and you decide which one to undeactivate, I guess. Let's put this whole thing a bit downwards. twist it like this, pull this out, pull this up, and if these three connect, you activate this one, you activate this one, and this way we have a beautiful structure that would be scalable if we were to scale this. The only the only problem is that we don't integrate these two, which would actually enable us to build a 255 addresses register. Well, I guess we don't want to build this. I guess this is overkill for many of our purposes. The way we could implement it is by building a 4-bit decoder, right? I'm quite happy with the fact that I actually fulfilled what I was aiming for. Rather what I promised in the beginning. Copy the structure, place it again, and then place it again. You go away, and we put you here. You are named argument 2, right? You are named result. This is where you go away. We're going to place it. Maybe we're actually going to. No, we are going to. Yes, we're going to place it in a recessed manner. Since I think this is cool. I don't know if that is a good reason, but this is the reason why I built it the way I built it. So we keep this one. So we want to remember, we put it here. And then left to right. Top to bottom. So we can remember how this is wired. Actually using custom components and building custom components. I don't know, always. Oh look, there's a way. There's a way we can deactivate these decoders. We could just go with one more, and then we could go Whoop. Whoop. And you would be able to address 4 of these ones, of these guys. Great. So we don't even have to build a... Hopefully. Oh my god, I thought I deleted it. Yeah. This way we can chain ourselves upwards. Don't even have to build a 4-bit decoder, even though the 4-bit decoder would be an amazing tool, definitely. Still going to keep this one open. We use this one for argument 1, so let's keep this going. You'll go here. You address the switches. And this is going to make a great register component for our lag architecture. No. I can actually tell you an anecdote from my life at this point, because this stuff is tedious and it's gonna take a while, and I just remember the story. But I don't know if this is the right place to do it. So there's that. I don't know if you're actually watching these videos and you enjoy them. Maybe you could comment if you would want that or not. So maybe it wouldn't be so... I don't know, dry only watching these videos. So here we are. Wiring up all this stuff. Close to the finish. And the cool thing is, if we were to scale this thing up, wait, I made a mistake, right? Yes. One too low. We're close to finishing this register component. The cool thing is, this is what I was going to say, is if we were to make this, like to scale this up, we would have an easy time making this into a variant where it would address not only 16, but actually 32 registers, and just for the sake of the argument, let's just do this. We can just copy this entire structure. It's not going to be that hard. So, to scale it, because we can just place this. Then what we would do is we delete these guys. We would delete these guys. These guys. No, not you. Then the next thing we can do is basically move these things. This one goes here. This one goes here. This one goes to argument 1. This one goes to result. And we would then take these guys. Oh, not like this. Connect them down here. It's getting big. Remember this level where they told us that it is so tedious to build a RAM? Well, now we're basically doing it. This is actually getting close to the no, not even close to the 255, but if you want to, if you would want to, this will definitely enable you to do it. And in a way that is not the worst thing in the world to do, right? If the game wasn't so laggy when moving these amounts of components, it would be, I guess, even more amazing, even though the game itself is utterly amazing anyway. really love it. Nope, not like this. How does this happen? I want to create a clean and just like up there, right? The shape of the component is not how I would love it to be. And I'm paying way too much attention to this. This is, I don't know, attention to detail. I guess. It's just how I am. Here we are. Little bit obsessive with these things. Here we are. We've just built. How many are these? These are 4, 8, 12, 16, 30, 32 registers. Great. This structure is actually going to come in handy if we were to ever actually build a RISC or an ARM CPU in this game, because all we would have to do is swap these registers for 64-bit registers, and then I'm not even sure if we would have to do that. Anyways, I think so. Not sure though. That will work. So, 32 registers. Amazing. Oh no, you're an input. Interesting. You're not an output. Here we go. Input, you are result. We name your result just as the this schematic. Wishes for. Oh, come on. And this way we can easily remember these things. Yeah, I'm quite proud of this. I like how this turned out in the end. So here we are. 34-bit addressable register. How do we name you? Oh, 32-bit addressable register. 32-byte. Maybe we can actually share this thing. CCO license? I have no idea what it does. Let's go. There's our register. And well, to leave the component factory, we want to go back to the level. Now we are going to place this register, and I guess building the register took long enough. This is it for this video. As always, I hope you had fun, and we're going to explore the game in more detail and the further levels in the next videos. Goodbye.